Another research direction, or another direction for comms at the moment, is green communication. Because there are excessive CO2 emissions in the world, the climate is changing. And before we can reverse the effects, we have to stop or reduce the CO2 emission dramatically. This hits the ICT community as well. For the ICT, the information and communication technologies, the ICT industry currently, globally, produces 2% of CO2. It is the same amount as aviation industry. We always thought that the airplane produces quite a lot of CO2. It's true. However, ICT produces the same amount of CO2. So it's a major problem. And it's projected that by 2020, it will increase to about 3% of global CO2 emission. So from a service provider's point of view, because there are more and more cellular sites, it requires more and more electricity. The electricity cost is increasing so high at the moment that the operational expenditure, or the OPEX, has increased a lot. They want to reduce the OPEX because on one hand, as I've said, they are losing revenue. On the other hand, the OPEX is increasing. So if they don't do anything, they will get less and less revenue back. So from an operator point of view, they want to come up with new green approach. By green, we mean that we will reduce the power consumption. These are the latest research directions, is to develop low power consumption equipment. The diagram, the figure over there, this is a base station, a very new design of base station by Ericsson. What they did is they call it tower tube. It is a green tower, a green transmitter that they consume about only 10% of a conventional base station. So there's a huge energy reduction there. And because what they do is they have special materials such that it can ventilate the heat quite well. Also, instead of the equipment being located on the ground, once they have set up the equipment, they lift it all the way to the top. So the equipment, instead of being down here, the equipment are lifted up there. The reason why the equipment is being up there is twofold. On one hand, is because if we have a shorter cable, because if the equipment is up there, very near to the antenna, the cable will be very short. With a shorter cable, the loss will be less. With a lesser loss, then of course you need lesser transmission power, which is better. On the other hand, is that if this base station is quite high, if we could lift it up, then because we know that the higher you go up, the cooler the temperature, the better the air ventilation. So because of that, the power consumption is also less. And in this particular figure, they also have a wind turbine. These blades there, they are not antennas, they are wind turbine. So if they put the base station with a wind turbine, what happens is the wind turbine will generate electricity by itself. For this particular model, they claim that they consume zero power because, well, of course, it depends on where they operate it. But if the wind turbine is working fully effectively, then they don't need extra electricity. The wind turbine will generate enough electricity to generate the power for the base station. So green communication is one of the key research directions at the moment, and this is also what the University of Manchester we are looking at heavily at the moment. The last slide is cognitive radio. You might have heard about cognitive radio. It's also a very hot research topic at the moment. It is the reason behind cognitive radio is because again, spectrum is very scarce and limited. But what's also found is that from measurements, so spectrum is not fully utilized. Quite often, the spectrum is underutilized. Quite a lot of spectrum is free. So instead of leaving them free, what about allowing other users to use the spectrum? From a service operator's point of view, what about if we could lease the spectrum to other operator? Then they could somehow recoup some of the revenue. So that is the idea of quantitative radio. So what quantitative radio does is that they will sense the spectrum. For a quantitative radio, it will sense to see if the spectrum is free. If the channel is free, then it will decide and manage how to use the spectrum. They could send at that time, or they could somehow do some clever thing with that. But however, at the same time, they will have to keep sensing. And once the licensed users comes back, they will have to stop transmission, because the licensed user, of course, has a higher priority. So this is the quantitative radio, and there is a new IEEE working group called 802.22, Wireless Regional Area Network, is heavily looking into using quantitative radio for wide network. It is a very hot research topic in the last few years. This is the last slide. I went through lots of things in wireless comms in just 1 hour. I hope you can understand what I've mentioned. For some faculty members, it might be a bit boring because you might have known all this already. But I hope for the undergraduate students, it will give you some insights into the challenges of wireless comms and also some of the latest research directions. Thank you.
Thank you very much, Dr. So. We're now ready to take any questions that anybody has.
I have one.
Okay, please go ahead.
Sir, will you please go to the slide where you have a brief introduction of WiMAX technology?
Please, can you repeat,
please? Sorry.
Sir, will you please go to the slide where you have a brief introduction of WiMAX technology?
Can we go back to the slide where we have production of, please, can you just repeat it again, please?
WiMAX technology.
IMAX technology.
Yeah. Oops. No. Yeah.
Yes, sir.
Is it this slide?
Yes, sir.
Yeah.
Sir, as we know that SL is a portion where base station is able to radiate, and so how it is possible that in WiMAX another base station is placed in the same cell which is using almost the same frequency without any?
Okay. Well, it's a good question. Well, first of all, is in one cell, in one of the cell here, the hexagonal pattern there, in here, there's only one base station. One base station, but